Hi guys, this is the South County Math Tutor here again with the College Algebra series. Today we are going to be on section one, unit one, section two, and we will be looking at one second. Okay, today we will be on 1.2, and we will be looking at algebraic expressions. Okay, so we'll be looking at other operations. We'll be looking at how to evaluate algebraic expressions. We will be writing verbal algebraic expressions, and we'll be converting written verbal. We'll be converting verbal to equate to expressions, algebraic expressions. So we do a lot of things with this. Okay. So what are algebraic expressions? Well, algebraic expressions are things that you've seen before. For example, 2 plus 3 plus 5 is an example of an algebraic expression. Just making a mathematical statement is what I call it. Or something like x plus y minus 3 or x squared. These are all examples of algebraic expression. One key thing that I want you guys to know is that algebraic expressions, they don't have equal signs. When they have equal signs, we call those equations. But if they do not have equal signs, those are considered expressions. Expressions don't have equal signs. Okay? So, before we do this, let's review order of operations. Okay? So, order of operations. Okay, an order of operations is a rule of how we do things in math. If, for example, let's look at some example. Let's say you had 2 plus 3 times 2 minus 5. Okay, how would you do this problem? Okay, well, somebody could look at this problem and say, okay, well, 2 plus 3 is 5. 5 times 2 minus 5, well, 2 minus 5 is negative 3, so the answer is negative 15. Okay, another person might look at this problem and say, well, we could do 2 minus 5 first, that's negative 3. We can just do backwards, 3 plus 2, okay, and they can do 5 times negative 3, which is negative 15, okay, same answers. All right, well, somebody else could also look at this and say, okay, well, I am going to do completely different method. I'm going to do the parentheses, negative 3, and then I'm going to multiply times 3 is negative 9. And then once I get that, I'm going to do 2 minus negative 9 is 7. You can say, well, wait a minute. These two people had the same answer, but this one is off. Which one is actually the right answer? Well, that is where the order of operation comes from. We need to have a systematic way of knowing who is right, and that knowing how to do operations so that everybody will understand how to do it, and it will always be right. So what is the order of operation? Well, we use this PEMDAS. Okay, PEMDAS stands for parentheses. These are the order in which we do things. Okay, the order of operation, how we solve mathematical problems. Exponents. This is PEMDAS with an M. Okay, I gotta erase that. Okay, and this is PEMDAS. I don't know how I got that M. Okay, exponents, multiplication. Division. Addition. Addition. and subtraction. Okay, PEMDAS. Okay, so this is the order in which we do math problems. Okay, it is a way that we will all do it so that we will all know the right answer when we see it. Okay, so based on PEMDAS, this is not going to be a good answer. Okay, because they did the parentheses, they added first before they did the parentheses. So this will not be a good answer. Okay, turns out that these people did the parentheses first, but they added before they multiplied. So this is not a good answer. Okay, this person did parentheses and then they multiplied and then they did the subtraction. So it turns out that this person, this lone answer that seemed to be the incorrect one because it was different from the other ones, is actually the right answer because of follow the rule that we use to do math, PEMDAS. Okay, there's many ways to remember. There's different ways to remember this. Some people say, okay, please excuse my dear Aunt Sally, PEMDAS. Okay, if you remember the word PEMDAS, you will remember which way to do this. Parentheses, exponents, multiplication, division, addition, and subtraction. Okay, so that is a reminder of what the order of operation is. Okay, now the next thing that we are going to do is, how do we evaluate expressions? Evaluating algebraic expressions. Okay, what does it mean to evaluate? Okay, evaluating, when you have an evaluation problem, you will usually have a variable and they will tell you what the variable is. And what they mean by evaluate is they want you to plug in the variable to figure out an answer. For example, example 1. Okay. Evaluate 2x plus 3y minus 3. For x is equal to 5 and y is equal to negative 2. Okay, so again, evaluating means to plug in. Plug in and simplify. Okay, evaluating is plug in and simplify. Okay, so step 1, plug in. Plug in your given. Okay, so what x equals 5 means whenever you see x, you're going to replace it with 5. Y equals negative 2 is whenever you see y, you're going to replace it with negative 2. Okay, so I'm going to try to color code. 2, every time I see x, I'm going to replace it with 5. Plus 3y, every time I see y, I'm going to replace it with negative 2. Okay, plug in. And then step 2 is simplify using your order of operations, and we know what that is, and it's PEMDAS. Okay, so we actually, inside our parentheses is solved, but whenever you have parentheses next to a number like this, that represents multiplication. So inside the parentheses is simplified because you have just one number, okay? But you can multiply next. 2 times 5 is 10. 3 times a negative 2 is negative 6. And then bring down your minus 3. Okay? Now when you get to this step, you just go from left to right because it's all subtraction. So you can do 10 minus 6 is 4, minus 3 is 1. So your answer is 1. Okay? So Let's give you a second example. Example 2. Evaluate 2m plus 3n, okay, when m equals a and n equals z. Okay, so you have letters, that's fine. You still can plug in because it asks you to evaluate. So wherever you see m, you plug in a. Whenever you see n, you plug in z. So you have 2. Instead of m, you're going to plug in a plus 3. Instead of n, you are going to plug in z. Okay, and then you evaluate. 2 times a is just 2a. 3 times z is 3z. Okay, what if you had the exact same problem? Example 3. Example 3. Okay, let's say you have the exact same problem. Actually, let's move this down a little bit. I can copy, so I'm just going to move this down just a little. 2m plus 3n. Let's say you had the exact same problem. Example 2. Example 3. Evaluate. Okay. 2m plus 3. Let's say that was 3n. But this time you have for m equals n equals 4. Okay, so this tells you m and n are the same and they both equal 4. So wherever you see n, you're going to plug in 4. Wherever you see m, you're going to plug in 4. Okay, so they just happen to be the same. 2 times 4 plus 3 times 4 times 4. Okay, and then simplify. 2 times 4 is 8. 3 times 4 is 12. So your answer is 20. Okay, so that is how we evaluate. Alright, now let's talk about the distributive property. If you had a number 2n plus 3 and they want you to multiply, okay, if you look at this expression, let's say versus 2, 1 plus 3. Well, if you have something like this, you can use your order of operations, PEMDAS. Parentheses first, simplify what's inside the parentheses. 1 plus 3 is 4. Times 2. Then you have 8. Now, this problem and this problem are almost the same, except for this has a number 1 plus 3 inside the parentheses. N plus 3, you can't do anything more to it because n plus 3 are not the same. So what you can do is what we call the distributive property, and that just means take the 2 and multiply it into the parentheses, just like that. So 2 times n is 2n, plus 2 times 3 is 6. That is your final answer. Okay? Well, I kind of went a little too fast for myself. Before we do distributive property, I just want to show you how to simplify. Okay, expressions. Simplifying the expression. Alright. So, for example, let's say you have 1. This expression 2k plus 3 plus 5n plus 6k minus 20 plus 4k minus 10n. Okay? To simplify is to make, I always tell my students, simplifying is make it pretty. Okay? If there are things that are alike, put them together. Okay? So another way to say this is to combine like terms. Take like terms, things that are the same, and put them together. Okay? So it turns out that like terms are things that have the exact same variable. Okay? So for example, 2k, 6k, and 4k are like terms. They all have k's, okay, just k's, k to the first power. So we go ahead and combine those. So you can do 2k plus 6k is 8k, plus 4k is 12k, okay, and that's the case. I like to underline, and once I'm done, I just cross out like this to show that I'm done. That way I don't go back and do it again. Next, I have numbers. 3. Okay, it doesn't have any variable. I have 3. I have another number 20. Doesn't have any variable, so those are like terms. Those are called constants because it's just a number. 3 minus 20 is negative 17. I'm done with that, so I just draw a line to scratch that out to remind myself that I'm done with it. Okay, so now I have positive 5n. So if you care about the number and the sign in front of it. Minus 10n. Combine those together, and this is negative 5n. Okay, I've made this pretty. There's nothing else I can put together. Those are like terms. They are all together, and this is my final answer. 12k minus 17 minus 5n. Okay, here's number 2. What if you have 2k squared minus 3k plus 4k minus k squared plus 2? Okay? They both have the same variables, k squared and k, okay? But it turns out that they are not the same. Okay? They are not the same. K squared has a variable to the second power is different from k. So the powers also matter. So 2k squared and negative k squared are the same, are similar, so you can combine them. Now, if you have a variable without a number in front of it, we always assume that that's a 1. We just don't write it because mathematicians, sometimes we can be lazy, sometimes we don't want to write everything. So we all understand that when you have a variable with no number in front of it, that's a 1. So this is 2k squared minus 1k squared, which is just 1k squared. 1k squared is the same thing as k squared. Okay, we're done with that one. Move on to the next one. Okay, 3k. Find another just k. Plus 4k. That's another just k. Together, that would give me 1k. Again, positive 1k. 1k is the same thing as k. Okay, and then I have this number by itself, so I just tag it along. Plus 2. And that is simplified. Alright, now we're going to go back to the distributive property. Again, notice this versus that. Distributive property. We would use PEMDAS. However, we have an n. An n and a 3 are not like terms. Okay, so you can't combine them. You can't simplify them any further. So now to multiply or to distribute, all you have to do is take the 2 and multiply it into everything that's in the parentheses. So 2 times n, 2 times 3, so it's 2n plus 6. Okay, let's try to combine all of these. Distribute, and simplify. Okay, so I'm just gonna go down the page. Okay, so example 1. 2, negative 2, k plus 1 minus 3, k plus 2. Okay, so again, if you look inside the parentheses and try to use the order of operation, you notice that the parentheses is already simplified. So next thing you do is use the distributive property. Negative 2 times k is negative 2k. You multiply the number and the sign in front of it. Negative 2 times 1 is negative 2. Notice the parentheses closes. It opens here and it closes here. That means that this part is done. So you move on to the next one. You see a number in front of a parentheses. That tells you to distribute. Negative 3 times k is negative 3k. Negative 3 times positive 2 is negative 6. And then now you make it pretty. You combine like terms. Negative 2k minus 3k is negative 5k. Negative 2 minus 6 is negative 8. And we are done. Okay, what if you had example 2? Negative x plus 7 plus 3 minus, let's make it plus 5y minus 2. Okay, so normally you would do PEMDAS and do parentheses first. But as you can see, the parentheses is already simplified, so you move on to the next thing, multiplication. Well, we have some multiplication. They are things in front of parentheses. Whenever you have a negative in front of a parentheses, you distribute it, and it turns out it's like multiplying by a negative 1. All that does is changes the sign of what's inside the parentheses. So negative times x is negative x, or negative 1 times x is negative 1x. Okay? Negative times positive 7 is negative 7. Okay, so you move on to the next thing. Plus 3. There's no parentheses, so you just copy it down, bring it down just like it looks. Plus 3 plus 5 is in front of a parentheses, so go back to distributing. Plus 5y minus 10. And then you combine like terms. You have an x, you look for another x, you don't have another one, so negative x. You're done with that. You have a number, another number, another number, put them all together. Negative 7 plus 3 is negative 4. Negative 4 minus 10 is negative 14. Okay? And then you have those 5y, you just write it plus 5y. Okay, so there we go. We talked about a lot of things on this section. We talked about algebraic expressions. We talked about order of operations. Okay, we talked about the distributive property. We evaluated, talked about the distributive properties. It's distributed and simplified. And let's do one more. Let's do some of the examples that we have on here. Let's see. Not there, but here. Okay, so here are some examples of PEMDAS. Here are some examples of, let's do 8 and 10. Okay, go back to this. Okay, that. Okay. Okay. Let's see, before we do that. Okay, so let's do this one. The question was to evaluate. Evaluate. It's important to know what the question is asking you. Evaluating is to plug in, okay, replace and simplify. nm divided by 4. When m is 4, so every time I see m, I replace it with 4. And every time I see n, I replace it with 5. Okay, so instead of m, I'm going to put 4. Instead of n, I'm going to put 5 times. Instead of m, I'm going to put 4 divided by 4. Okay, so this is an order of operations problem. Here I'm multiplying and division. 5 times 4 is 20. Divided by 4 is 5. Alright, what if we have squares? Again, replace. When I see y, I'm going to replace it with 1. Instead of y, I'm going to have 1. Instead of z, I'm going to have 3. Okay, so 1 plus 3 squared. Order of operations. Are you going to add before you raise to the power of 2? No, because exponent comes before addition. So what you want to do is 3 squared is 9 plus 1. 1 plus 9 is 10. Okay, always use your order of operations. Okay, so next thing is, let's go to the final thing that I have here for you guys. Writing algebraic expressions. Okay, so taking words and writing it in algebra. And again, I click on the wrong thing. That's okay. Okay, so let's go here. Writing algebraic expressions. Okay, well, we can start with write into verbal expressions. Okay, so fine. Alrighty. So how can you say this in word? Well, like you would say it, a times 7 is a good answer. A times 7. There are other ways you can write this. The product of a and 7. You can also say multiply a by 7. There are many ways you can write this, and that's okay. How about 47? A lot of you probably look at this and just say x minus 8. Okay? Here's another one. Here's a good one. 8 less than x. Okay? That's an important one that we're gonna look at really soon. Okay? Is there any other way you can think of? Subtract 8 from x. Okay, remove 8 from x, subtract 8 from x. Those are all good ways to say that. Okay, so we need to be very careful with this word less than or subtract form. So let's look at regular examples that don't have variables. So let's say 7 minus 2. If we were to say 2 less than 7, that would be correct because 2 less than 7 is 5, right? But if we said 7 less than 2, it means that we have 2 and we take 7 away from it. Okay, so those less than, how I see it is, if you ever see the word less than, know that it's a switch word. Okay, so when you're trying to write it back in algebra, it's actually going to be 7 minus 2. Okay, same thing for greater than, same things for add to. Okay, I will compile a worksheet for you that will have a lot of these things in them. Now, what if, let's do one more and then we will go ahead and take a break from this section. Let's see. Let's go ahead and do the first two. Write as an algebraic expression. Write as an algebraic expression. Okay. Okay. So 3 less than v. Again, here's the word less than. Switch word. So it's not going to be 3 minus v, it's actually going to be v minus 3. Okay, which will make a difference because if you think about it, let's say v was 10. 10 minus 3 would be different from 3 minus 10. 10 minus 3 would be 7. 3 minus 10 would be -7. So those things are different and it's important to know. 5 cubed. 5 cubed. 5 to the third power. Okay, so thank you so much for joining me for this second part 2 of our college algebra video series. I hope you understand this. I would like for you to go ahead and do the 1.2 assignments and review your notes. Thank you.